The internal combustion engine was invented over 100 years ago. Today it has been developed into a powerful and reliable power unit, although the basic principles of its operation remain exactly the same. At first glance, the modern petrol engine seems very complicated. But cut it in half, and the fundamental principles will be easier to understand. There are three main sections to the engine. The sump, holding the oil. The cylinder block, which holds the crankshaft and contains the cylinders and pistons. And the cylinder head, holding the camshaft, the valves, and the spark plugs. To help us understand how the engine works, let us take a simplified model engine. When pressure is applied to the top of a piston, it is driven down, causing the crankshaft to rotate. In this way, up and down movement is changed to rotary motion. Now, when starting, the starter motor turns the engine until a mixture of fuel and air is sucked into a cylinder on the induction stroke. Then, as the piston is forced upwards on the compression stroke, the mixture is compressed into the combustion chamber. Then the mixture is ignited and the piston is driven down by the expansion of the burning gas on the power stroke. On the following upward stroke, the burnt gas is driven out. This is the exhaust stroke. This is known as the four-stroke cycle: induction, compression, power, and exhaust. Gases enter and leave the combustion chamber through openings called ports, which are opened and closed by valves. The valves are opened by cams on the camshaft and closed by springs, and operated in timed sequence to the pistons. On the induction stroke, the inlet valve opens and the air-fuel mixture is sucked in as the piston falls. The valve closes. Because both valves are closed, the mixture is compressed by the rising piston. With the inlet and exhaust valves closed, the mixture is ignited by the spark plug. The piston is driven down by the energy released. As the piston begins to rise again, the exhaust valve opens to clear the burnt gases. The valve closes and the cycle can begin again. To reduce vibration, firing occurs at evenly spaced intervals. On a four-cylinder engine, the firing order is usually 1, 3, 4, 2. Air and fuel must be mixed in the correct proportions. When a carburetor is fitted, air is sucked in and passes a jet, where fuel is drawn into the airflow and mixed with air before entering the combustion chamber. Instead of a carburetor, some engines are fitted with fuel injection. A metering system, connected by pipes, ensures that each cylinder gets exactly the correct amount of fuel. A turbo unit provides a more efficient air intake by forcing air into the engine. The hot exhaust gases drive a turbine connected by a shaft to a compressor, which forces air like a fan into the intake system. The ignition system consists of a battery, a switch, a coil, and a distributor. A low voltage from the battery goes through the switch to the primary coil of wire inside the high-tension coil. When the low voltage circuit is interrupted by a contact breaker under the distributor cap, a very high voltage of short duration is induced into the secondary coil, which causes a spark each time the circuit is broken. The spark is synchronized to the start of the power stroke. For increased efficiency, some modern engines are fitted with electronic ignition to replace the contact breaker. But the purpose remains the same, to produce a spark at the right time. Most engines are cooled by water, which is stored in the radiator and connected by hoses to the engine, where it circulates through channels surrounding the cylinders and the combustion chambers. The water is driven by a pump through the engine and into the top of the radiator, where it is cooled by the airflow and returned to the engine through the bottom hose. All engines require lubrication to reduce friction between the moving parts. The system comprises a sump to contain the oil, a filter, and an oil pump. The pump forces the oil through internal oilways to parts requiring lubrication. Many different engines are designed in the quest for more power, increased reliability, better fuel economy, and lower exhaust emission. Some engines have few cylinders, and others have many. Some have carburetors, and others have fuel injection. Some are turbocharged, and many have advanced electronic control systems. But most work on the same basic principles: induction, compression, power, exhaust, the 4-stroke cycle.